Today's lesson is 1.3 midpoint and distance. After today's lesson, you should be able to find the midpoint of a line segment and the distance of a line segment. We've already talked about midpoint. Midpoint is in the exact middle. However, we're going to look for the coordinate of the exact middle of a line segment if it were on a coordinate plane. So for example, if we look at example A, when we're talking about the coordinate plane, we are talking about our four quadrants, and I would plot the ordered pair 2, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Remember, our ordered pairs are always x, comma, y, so that 2 tells me to go right 2, and then I go up 6. So I'm going to plot my point at A. And then we have point B, which is at -4. So I go left 4, and then I go up 3. 1, 2, 3. And there is B. This is my line segment on the coordinate plane, and my goal is to find the ordered pair that would be in the exact middle. Now, I don't know exactly where the middle is. I'm just guessing it's somewhere around there by eyesight, but I am looking for what x value and what y value would that midpoint be at. We do have a formula to find this, but I want to talk about kind of where it comes from. So if I ask you the simple question of what's halfway in between 10 and 50, you could easily tell me that that is 30. And here's how we know that. If we look at the number line, 10, 20, 30, 40, and 50. Here is 10, here is 50, and 30 is in the exact middle. Well, mathematically, really what you've done is you have taken 50, you've added 10 to it, so you've added 50 and 10 together, and then you've cut it in half, because 60 divided by 2 is 30. So 30 is in the exact middle. So in other words, you're finding the average. So what I'm actually doing to find this midpoint is I am finding the average of my x values of each point. So I'm taking what my x value is and finding the average. And then I'm also doing the same thing for the y value. I'm finding the y values and then finding their average to get my midpoint. So you have two averages to find. You have to do it with the x values and the y values. That's where our formula comes from. So I would get in the habit of naming each point, one of them x1, y1, and then the other one you are going to name with x2, y2, just to denote there's two different ordered pairs. So the first thing we want to do always is average your x values together. So my x values are 2 and -4. So I'm going to add 2 plus -4 together, and then I divide that by 2. Well, 2 plus -4 is -2, and a -2 divided by a -2 would give me a -1. Then I have to do the same thing with my y values. I am going to average my y values. So I'm going to add 6 and 3 together. 6 and 3, and then I divide that by 2. Well, 6 plus 3 is 9. And if I take 9 and divide it by 2, I get 4.5. So my midpoint, M, is at -1, 4.5. So I can kind of visually see over here that I went left 1, and I did go up, oops. I did go up 1, 2, 3, 4, and it looks to be about halfway between 4 and 5. So that's approximately at -1, 4.5 on my drawing. So we're going to do the same thing with Q. Q is the midpoint of the segment. That should probably say M. I am so sorry. M is the midpoint of segment PQ. So if my endpoint P is at 1, -5, I'm going to come through and I'm going to label this point x1, y1. And then I'm going to label Q x2, y2. And I'm going to locate where the middle of that line is. So I'm going to find the average of my x values and the average of my y values. So let's average our x values first. I'm always going to take my x values, 1 and -4, and I add those together. 1 plus a -4, and then I'm going to divide by 2. Well, 1 plus 4 is -3, and if I take -3 divided by 2, I'm going to get -1.5, -1.5. Then I do the same thing with my y values. I'm going to take -5 plus 1, -5 plus 1, and then I'm going to divide it by 2. Well, -5 plus 1 is -4, and then we're going to cut it in half. Well, half of -4 is -2. So my midpoint, and I'm sorry you can't see that because of the watermark, so I'll rewrite it where you can see it. My midpoint is at -1.5, comma, -2. And you don't have to draw the coordinate plane every time, but it does give you a visual to see if your midpoint looks accurate. So that's how we find the midpoint, the coordinate of the midpoint of a segment. Then we also have distance. So I'm going to show you kind of where the distance formula comes from as well. So I'm going to take example 2a, and I'm going to plot that on the coordinate plane again. So I'm going to plot 2, 6. So I'm going to go right 2 and up 1, 2, 3, 4, 5, 6. And I'm going to label that with A. And then I'm also going to plot -4, 3. So I'm going to go left 1, 2, 3, 4, and up 1, 2, 3. I'm going to label that B. And then I'm going to connect that with a line. So I am trying to find the length of that line, and I can't find the length of that line segment very well because it's not horizontal or vertical, it is slanted. But what we can do is we can create a right triangle with that slanted line. So I can make a right triangle with segment AB. And I'm going to put a right triangle, a 90-degree angle symbol in the right corner, because what you learned with right triangles in a previous class is the Pythagorean theorem, which says that a squared plus b squared equals c squared. And this c is always your hypotenuse, which is the slanted side across from the 90-degree angle. So it is the pink side. So in this case, it is our unknown side that we're trying to find. Now, since I drew a horizontal and vertical line, we can actually count those distances very easily. If I count the yellow distance, I'm 1, 2, 3, 4, 5, 6 units long. So this side has a length of 6, and my blue side has a length of 1, 2, 3. This one has a length of 3. The other two sides are your A and B. So I can substitute 6 in for A, and I can substitute 3 in for B. And so I'm going to be taking 6 squared plus 3 squared. And then I am looking for that third side. You know that 6 times 6 is 36. And 3 times 3 is 9. And if I add those two together, we're going to end up getting 45. So I now have 45 equals c squared. Well, c is not by itself yet, it is squared. So I have to do the inverse operation of squaring something, which is to take the square root. So if I take the square root, we're going to approximate that today with the calculator. So you're actually going to click the square root key on your calculator, then type in 45 and then equals, and we're going to round that to the nearest hundredth. Well, my calculator spits out 6.708, but the nearest hundredth would be right here. So I look to the right, and 8 is closer to the next whole number. So I'm going to round this to 6.71. So the length of segment AB is 6 7/71. Now, I'm going to show you how to use the distance formula because you might not want to draw a right triangle and use the Pythagorean theorem every time. So again, we always label our ordered pairs x1, y1, and x2, y2. So that's just how we're going to name them so we don't get confused. So if I come down here and I label A with x1, y1, and then I label B with x2, y2, really to find the distance of 6, this yellow line that I have right here, all I did was find the difference in the x values because that is on the x-axis. So that is why this first part of the equation says subtract your x values, because when you subtract your x values, you're technically finding this distance across your x-axis right here, which is going to be 6. So we can see that. So I'm going to put my large square root, because it's always, the formula is always the square root of, and then I'm going to take the difference of my x values in this first box. So I'm going to start with x2, which is -4, and I'm always going to subtract x1, and in this case x1 is 2, and then that's always squared. And you will notice that if I take -4 minus 2, that gives me -6, and -6 squared is 36. Well, if you look at our original work, that's exactly what we got over here. We used 6 and then 36. So those numbers are coming from the same place. Then we do the same thing with our y values. We are finding the distance of the y values. So this time, I should be getting 3 because that's what it was in our triangle. So I start with y2, which is 3, and I subtract my y1, which is 6, and 3 minus 6 is -3. Well, if I square -3, -3 times -3 is 9, and I end up with the same result, which is the square root of 45. So that's still 6.71. So you are taking your x values and subtracting them, and then squaring them. Then you do the same thing with your y values. You subtract them and square, and then you add those together and take the square root. So that is your distance formula. So we're going to try one without drawing it out. So I'm going to name my first point x1, y1. And I'm going to name my second point x2, y2. And we always have the square roots. And then we always take the difference and square it, plus another difference and square it. And then we can start filling in what we know. So my first one is always the difference of my x values. So I take x2, which is -4, minus x1, which happens to be 1. And then I do the same thing with the y's. I take 1 minus, and then my y1 is -5. And then we're actually going to do that math. So we have -4 minus 1. If you owe someone $4 and borrow one more, that's -5. Keep that squared there. And then 1 minus a -5. You have to remember from last year that minus a negative or subtracting a negative really means to add a positive. So that is really 1 plus a positive 5, which would be 6. And then we get to square those. Negative 5 times negative 5 is 25. And 6 times 6 is 36. So then we're going to take 25 and 36 and we're going to add those together to get 61. And so we have to find the square root of 61 to the nearest hundredth. So I'm going to type square root 61 equals, and then my calculator says 7.810. This is the nearest hundredth. Since 0 is less than 5, it stays 7 and 81 hundredths. So the distance of line segment PQ would be 7 and 81 hundredths.